So we are in March 31/21. I have made some homework. You have 2.6 due Saturday. I'm almost done making 2.7. We'll make that one next Saturday. So try the homework. I am going to be updating Canvas, also going to work on grading exams tomorrow, or actually for you guys, it would be the quiz and getting the exam grades on Canvas to the gradebook. We're doing the rest of 3.1, and then we're going to go over 3.2. That's today's goal. Okay. More homework coming soon. Let's see. I have the last part of 3.1 and actually want to go over a few things that we did last time. So I can sort of remember. We had a function f of x equal to a to the x. And then we did the derivative f prime of x would be a to the x ln of a for the function e to the x. We did the derivative and got e to the x. What we're doing today is just an example. Okay. So this is all 3.1. We've got 3 to the x minus 6 root x minus e to the x. And then we'll take the derivative of f. Oh, right now, no quizzes to work on. We'll talk about a quiz maybe next week, but I am definitely gonna wait till I grade quiz 1. So thank you for the question about the class. Right now, all you have to work on is some new homework. F prime. We'll do this piece by piece. So 3 to the x ln of 3. I also feel it would help to rewrite the function, and then we'll go back and continue the derivative. 3 to the x is fine. 6x to 1/2, and that's okay. So the power rule will have a negative 1/2 times 6, x to a 1/2 minus 1, minus derivative of this. We've just talked about. We could rewrite this if you want to, but it looks okay to me. Anyway, if you would like to take care of that negative exponent, we get 3 over, let's call it root x. So 3.2 is the power rule and the quotient rule. We'll do 3.3 next time, which is where we take derivatives of trig functions. Start learning those rules. Oh, I'm sorry, not power, product rule. Product and quotient. That's better. Let's do the product. So for functions f and g, we'll just jump into the derivative of f times g. The derivative with respect to x, or d dx, of f of x times g of x. We're going to write it a few times. So just repeating the same thing in different notations. We'll have d dx of f of x times g of x plus d dx of g of x times f of x. Try this one more time. Another way I wrote this was, let's see. To have the derivative of f times g equal to f prime times g added to g prime times f. So I've got a couple examples, but I grabbed a book so we can try some more examples because I kind of like this rule and I like the quotient rule too after we practice. Okay, first one. Okay, h of x is the function 3x squared plus 5x minus 1. Multiply that with 7 to the x. So I'll call this f. This is g. And then get the derivative. We'll call h prime of x and write a little formula and then actually do each piece. Derivative of f. So let's go ahead and get the derivative of just what's in parentheses. 6x plus 5 minus 0. Times that function, 7 to the x. Add g prime. Derivative of this was 7 to the x, ln 7. We'll add it down here, but multiplied with the whole function in parentheses. We're going to call the function v, and let's do v of t. Will be e to the x times 3x to the 5th. This is my f. This is g. The derivative v prime of t will be f prime times g plus g prime times f. Derivative of f is the derivative of e to the x is e to the x times the function g. Add. Well, just to be safe, we'll add here. G prime. Derivative of this would be 15x to the 4th. And we'll take that, multiply with f. I did factor out the e to the x, and also I took out 3x to the 4th. Okay, so what are we doing? Let's try one more. And then we're going to go through the proof. I'll call this function capital P of x. And it is okay, we'll do 5 to the x to root x. So this part we'll call f. This will be g. And find p prime of x, or the derivative with respect to x. We do d dx of p of x. Say f prime g, add g prime f, and do the work. Derivative of 5 to the x will be 5 to the x ln of 5. Times the function g. Okay, so this will be 5 to the x times 2, x power 1/2. So derivative of g will be 1/2 times 2, x to a negative 1/2. So that 1/2 times 2 is a 1, x power negative 1/2. G prime times function f 5 to the x. Let's start the proof. Again, I didn't really introduce anything. I just jumped into taking the derivative. Part of me wants to check if we need conditions for our functions. Be right back. Well, okay, that's probably all that we need to say. F and g are differentiable, then we can start to take the derivative of f times g. And g. Okay, we'll have the derivative of f times g. So the limit as h goes to 0 of f of x plus h times g of x plus h. I'm just going to need to recopy this and get some more space. So functions. Are we here? Cool. Okay. So we're doing this proof for derivative with respect to x of fx g of x. This is the definition. The limit as h goes to 0, input x plus h, take away plugging in just to x. Over h. So we do a little trick where we add and subtract the same number. Here's the limit as h goes to 0. F of x plus h. G of x plus h. Okay, right here. It's subtract g of x plus h times f of x. And then add the same value. Add g of x plus h f of x. This piece is at the end. It's all over h. break this up into two limits. So the limit as h goes to 0 of this part of the numerator up till the plus sign over h. And then the same limit as h goes to 0 of the other piece over the denominator here. F of x plus h. Actually, when we do this piece, from the numerator, we will factor out g of x plus h to the side. Times f of x plus h minus f of x. The other limit will fit actually underneath. So plus the limit as h goes to 0 of this part, which will factor f of x out of to this side. So f of x times g of x plus h minus g of x. Make sure I have that right. So g of x plus h minus g of x. Okay, now the next step is to actually let h go to 0. Right here, this h goes to 0 and you get g of x, and then times all of this piece here. And that is f prime of x. Add this f of x, just f of x. This g of x plus h. G of x plus h minus g of x over h. That's g prime of x. And I feel like we can do one more example and then the quotient rule, which we won't prove, we'll just practice. Okay. So again, we let h go to 0, this h is going to go away. This part is the definition of f prime of x. This function is just sitting there. This is the definition of g prime of x. Oh, okay. So usually we do call functions f, so I would still, you can still call it f and g, even though you already have an f sitting there. Or we can use something else. We could call it, let's just do a b. F prime of x would be a prime b plus a prime a. Actually, this looks nice. Derivative of f of 5x 5 times the other function. derivative of what's in parentheses would be 2 plus 0. So just 2 times function 5x. Well, you know what? We can make this look a little better. Let's go a little further. So 10x, add 5e plus 10x. Cool. All right, I got 20x. Add 5e. That looks nice. Nice enough. So the rest of this section is just one more rule. Again, f and g are differentiable. Okay, the derivative of f of x divided by g of x. I guess we need g of x to not be the 0 function. So again, we will write this a few times in different notations. There's also a way to kind of a rhyme to help memorize this rule and then practice. So it's the derivative of the top function times the derivative of the bottom function. D dx f of x g of x. Subtract derivative of g of x times f of x. D dx g of x f of x. And then divide everything by g of x squared, the bottom function squared. And that's it. So derivative to top times the bottom, derivative of the bottom times the top. Subtract that part, and then divide by derivative of the bottom squared. Okay, or it just says or. Do f over g prime equals f prime g minus g prime f over g squared. Double check. Okay, that's good. And let's see, I did it one more time, and then we'll talk about the way to memorize it. It's the same thing, really. F of x over g of x. Take the derivative. B f prime of x, g of x. minus g prime of x fx over g of x squared. So I'll just say it a couple times and I'd actually kind of write it out. It doesn't really look, it doesn't, it's just a little rhyme. So this is to help memorize this rule. The derivative of f of x over g of x, we'll call f of x, since it's on top, it's high. And g of x is in the bottom, so it's called like low. And I've just heard this a few times, mostly in a math lab where like a tutor's kind of helping out. You have low d high, derivative of the top, minus high d low, square the bottom. Away we go. So again, let's see, high d low, low d high, square the bottom, good to go. Okay, I think we could also just practice. So we have an example. Let's call this h of x. We will do 7x over 3x squared minus 2. 7 to the x. So this would be f, and this would be g. H prime of x will be low d high, g of x times the derivative of f of x minus high d low over d squared. Make sure I did it again. Hang on. Is this wrong? D high, so f prime g of x. Is this correct? I'm trying to use the rhyme. Did I get this right? F prime g minus g prime f over g squared. There we go. Derivative of 7 to the x is 7 to the x ln of 7 times g of x. And subtract. F of x times the derivative of this denominator, so 6x minus 0. It's over 3x squared minus 2 squared. We're just going to leave it there. Next one, we'll have a function we'll call we can do v of x. Example. It's a function where we've got x to the fifth over 1 minus x cubed. And find v prime of x, or the derivative of v of x. We have this f as our numerator, the function g is the denominator, and we'll use the rule. Low d high minus high d low over bottom squared. Double check it just in case. Looks okay. And now we actually do this process. G times f prime. Then subtract. F times g prime. Here we'd have 0 minus 3x squared. And it's over 1 minus x cubed squared. And I think we could simplify this, but I'll leave that to you. So that's the answer. It could be written nicer. Let's try another practice problem. I think it would be cool if we had something like, we'll do like p of x, capital P of x. Let's do x cubed minus 3x over, I'm thinking like 4 to the x would be fun. Find p prime of x. Then maybe this will be it for today. Let's call the numerator f. This is going to be g. And we have low d high, so the bottom function times derivative of the top function. Subtract high d low, so the top derivative of the bottom. Square the bottom. All right. G is 4 to the x times f prime 3x squared minus 3. Subtract f times g prime. So everything in parentheses here. It's not going to fit. Okay, so what's in brackets will all be the numerator. It's just because I don't have space on the whiteboard. So this divided by the function g squared. But let's subtract f times g prime. And then divide all of that numerator by 4 to the x squared. which in this case you could write 4 to the 2x. I'm just going to leave it there though. Okay, so that's the end of this chapter, and we're just learning more rules for derivatives. So next time is trig rules. I think after that we do the chain rule, and I'm just going to continue to make some homework. So that's the end of the meeting.